Welcome back. There is a theorem that states anything that can be implemented recursively can be implemented iteratively. That is, you can go your whole life without implementing recursive functions and just use loops. Okay, so why would we ever want to confuse ourselves with a topic like recursion that can be a little confusing? Well, for some problems, it's actually easier to write, but it really depends on the situation. Keep in mind that there's always two options. And by now, you know that with programming, there's always pros and cons. And a good engineer is somebody who can make the right decisions based on those pros and cons. But I want you to keep this in mind for interviews, because interviewers will ask you to solve a problem. And a problem that can be solved with recursion can usually be solved iteratively as well. And looking at our Fibonacci function, this is a simpler example of recursion. But there are times when recursion can keep your code dry. That is, do not repeat yourself. A big rule when it comes to programming. And there are a lot of problems when it comes to recursion as they get harder and harder when using recursive functions allow your code to be more readable and also dry, simpler, have less loops happening with confusing code. And I'm a little bit biased because although recursion is a powerful technique, in my opinion, it's not always the best approach. So you need to make sure because of, or its main drawback. That is, although recursion can keep your code dry and make your code more readable, it also creates this extra memory footprint. Because every time we add a function to the call stack, it adds extra piece of memory. So you have cases where you can get stack overflows. Or if your system has expensive memory, you want to avoid making too many recursive calls. And for some people, recursion is also something that is hard to wrap their mind around. And if you have a team of young engineers, of developers that aren't familiar with recursion, that may not be the best option. But the main drawback is this, that iterative approaches tend to be more efficient because they don't make these additional function calls that take up the stack space, with the downside being that iterative solutions might be not as readable. And the rule that I like to follow is that I like to use recursion when you're working with data structures that you're not really sure how deep they are, where you don't know how many loops to go through. And as you'll see, recursion is really useful for things such as tree data structures and doing traversal because that is often the case. Now, in the next video, I want to talk about this topic a little bit deeper and when to use recursion. But I do want to point one thing quickly. There's something called tail call optimization in many languages. And for example, in JavaScript with ES6, it allows recursions to be called without increasing the call stack. You can read more about it in the resources that I'll provide to you in this video. But in other languages as well, there are certain ways to write recursion so they're more memory efficient. So this large stack issue can actually be resolved during production. But let's talk about a definitive guide to when to use recursion in the next video.